Tonight from the University of California, Davis, I'm George Strait, and this is State of Minds. This is the magnificent Mondavi Center for the Performing Arts, an architectural jewel that attracts artists and entertainers from around the world to this campus, one of 10 in the University of California, where every day students, faculty, and staff pursue knowledge in the public interest, showing once again that California is a state of minds. UC Davis is located in California's vast Central Valley. It's about 15 miles outside of Sacramento, the state capital. The campus began as the university farm in 1906. The state legislature required that researchers emphasize the study of viticulture and enology, which are the arts of growing grapes and making fine wine. All of that came to a halt in 1919, but with the repeal of Prohibition in 1933, research resumed in earnest. And that work at what had become UC Davis helped create the multi-billion-dollar wine industry in California. Grateful vintners showed their appreciation by supporting new research projects and student services, and in this case, funding this center and the upcoming Robert Mondavi Institute for Wine and Food Science. Now that's my kind of institute. UC Davis is home to some 30,000 students who study everything from the Vietnam War to veterinary medicine. And as Paul Fontenauer reports, many students here have the rare opportunity to learn what to do when someone yells fire.
Inspire a shared vision, to challenge the process, enable others to act.
UC Davis is one of only 3 universities in the country that has its own fire department and a student residency program that gives undergraduate and graduate students an opportunity to work alongside career firefighters. Alumni from the firefighting program have gone on to work in fire departments throughout the United States. Some have stayed local, including the assistant fire chief, Wes Arvin.
You know, it's one of those things where you get bit. And you get bit by the bug is what we call it. The fire service is one of those occupations where it's basically the same thing every day, and that is variety.
Will Winthrow, a mechanical and aeronautical engineering graduate student, has been bitten by the bug.
You could come to work and get a big structure fire or run some interesting medical calls. So you never know what's going to happen. I think that lack of rigidity is something that's very appealing to me.
UC Davis students apply for just 15 coveted spots in this elite program, which includes both in-class and hands-on training.
We're going to have a live victim on the 4th floor, simulated victim, that we're going to put into a Stokes, we're going to lash in, and we're going to slide down the ladder.
Okay, you can go ahead and unclip him.
Student firefighters take advantage of the campus's physical layout, which includes the tallest buildings in Yolo County.
They get to actually apply what they've learned in classes and through lectures that we've given them, so they actually get to apply it, get to use it on an actual person, and actually get to see how it works in different settings. And just like anything, if you don't use it, you lose it.
Ces Mercado, not unlike many career firefighters, first became interested in the firefighting program on campus when he was a pre-med student.
It opened my eyes to a whole new career path. I liked what I was doing. It was something that I could definitely see myself doing. Every single aspect of the job interested me. And just the teamwork, the camaraderie that we built here, I just wanted to continue to pursue it.
Students say the program provides a nurturing environment, and they love being a part of the firefighting family.
They're really good role models, and they make you want to become a firefighter. What
better connection is there to the campus community than to have a student program? That keeps us connected. We know what's going on with the campus community. We have new life that comes into this program every year. Every time we hire a group of students, it's a new infusion of energy that comes into the program.
That's one of the reasons I chose to work here, is that it's all about the resident program, is that you get to teach them and you get to slowly mentor them up to a point where they want to continue their career in the fire service.
And hand them off to somebody who's...
For every drill, a captain assesses and reviews its level of success with the team.
If you're already lifting up the patient, weighs what, 180 pounds with the patient and equipment, instead of raising it up to handrail level, you're having to raise it up to however high the ladder was above the handrail.
The resident student firefighting program benefits the entire department.
They bring a youthfulness and a vibrance and just a willingness to go get them and gung-ho that comes with that age. The students that are in our program are very, very fast learners because they're at UCD. They got into school at University of California at Davis, and it takes a certain aptitude and level of knowledge and experience to get in here. So we have reaped the benefit of having the cream of the crop as our resident firefighters.
50 years ago, UC Davis developed the student firefighting program, giving students the opportunity to learn firefighting skills.
Had you looked up, you would have seen that there were some obstacles in the way. You actually had to go over to the inlet, come back around, bring it back around the tree and then back to the inlet again. Would have been a little faster if you had just been aware of your surroundings. Walk around the tree to begin with and up to the inlet.
We're at an ag school, we're out in the middle of nowhere, and there wasn't going to be anybody else to come help fight our fires. So we put the program together, the campus did, in 1955.
Have her put her hand all the way into the glove.
In addition to firefighting skills, the students learn technical rescue and hazardous materials training.
Well, as a student, you are put through the basic hazmat class of being a first responder, and that's a week-long course which gives you the nuts and bolts to be safe.
Camaraderie naturally forms when the students eat and sleep at the fire station.
The students don't receive any monetary compensation, but in return of working about 90 hours per month on average, we receive a free room to live in at the fire station.
Although many student firefighters go into the program with no intention of making the fire service their careers, some end up catching the bug.
It's a great program. I think just the firefighting profession has that draw. Once you get into it, you realize how great it really is.
It's a family. You build the friendships that really last a lifetime.
13 of the 15 students who were part of this program in 2000 became career firefighters, and 2 are medical doctors. Students who are drawn to this work come from a wide variety of majors. As an undergraduate, Nate doubled in sociology and communication.
I didn't know from when I was a little kid, I didn't know, oh yeah, this is what I want to do with my life. But when I saw it, I was really interested in it. I had been interested for quite a while. And then just going through the process here was a wonderful experience, and I fell in love with it. And once I started doing it, I knew right away.
Part of the career change thing, I'm sure a lot of parents are cringing at this, but the job is such a rewarding job. In addition to that, we are a group of people who not only are willing to, but enjoy and thrive on going out and assisting people who need help.
You want to grab a radio?
Just how good are these students when they complete their residency? The reputation of this program is so good that many students are hired immediately because of their advanced training and learned skills.
After 50 years, this program's pitch to the students has remained the same. The ad says no experience is necessary, just interest and enthusiasm. Of the 500 students who have participated, 1/3 have become professional firefighters. Paul Fotenauer reporting in Davis.
As you might guess, I'm in the wine cellar of the Viticulture and Enology building here at UC Davis. This houses the largest archive of California wines, and students come here to study the history of wine, as well as how flavors and colors have changed over time. Maybe we'll save this for just a little bit later. And turn now from taste to technology, and a new robot called RP6, which is turning heads in local hospitals. Nancy Williams at UCLA has the story.
It could have come from the set of Star Wars, R2-D2, or remember Rosie from the Space Age Jetsons? But this robot is ushering in the 21st century of medicine.
All of them. All the beds are filled. We actually have 2 empty with admissions coming in.
It is the first robot in the world to make the rounds in a hospital intensive care unit.
We know that when a crisis occurs in the intensive care unit, the outcome's invariably better if you can respond within a matter of minutes. He had this surgery to remove this abnormality in the brain yesterday, and we're going to check and see how he's doing up in the intensive care unit now. So let's log in and see. What we're doing now is enabling our physicians to respond to crises in the intensive care unit just as if they were standing at the bedside through telemedicine, through robotic telemedicine.
Doctors at UCLA teamed up with a company in Santa Barbara, California to create the robot called RP6, a revolutionary combination of robotics and telecommunications that uses the internet.
So hi Tim, how are you doing today?
Pretty good.
Good, great. I've got a couple of quick tests for you. Let me see you hold up both of your hands. Open and close your hands. Okay. That's good. All right. I want to see you hold both your hands in front of you, just like this.
We're able to beam a person from anywhere to anywhere else in the world that the internet takes you to. For example, we've been able to beam people from, say, UCLA into Japan or into Europe or just down the street because the internet's really everywhere.
The doctors also designed a comprehensive patient information system, so this robot comes to the bedside prepared.
All right. Well, it looks like you're doing great as far as I'm concerned. Let me talk to Dad here for a second. So I can simultaneously get the human view of what's going on at the bedside and look at all of the scientific and quantitative and medical data on the patient through the second screen.
Talking to the doctor in terms of a robot almost seemed like he's just right there as a normal person, except because of the images on the screen.
Right, now touch each finger again.
RP6 was originally designed at UCLA to combat a growing national shortage of intensivists, doctors who care for the critically ill. But for this robot, there's no telling what the future may bring, in a world where science fiction is fast becoming more science than fiction.
In military situations where there may be an advanced field hospital that doesn't have neurosurgeons and cardiac surgeons on site, where these kind of specialists can interact with the battle casualties right on the spot. In the future, International Space Station, the mission to Mars, I don't know, but I think that this kind of ability to act and render care and make decisions at a remote location, I think, has a tremendous utility in the future.
This is Nancy Williams at UCLA.
Now, if only that robot could cook. Behind me is Puda Creek, a tranquil spot on the Davis campus. This is the kind of place that nature lovers really treasure, and well, they should. Protecting the environment drives a lot of the research at the University of California, none more so than at UC Riverside, where engineers have taken common trash, that's right, common trash, and figured out a way to turn it into fuel. Jim Brown explains.
7 years ago, Joe Norbeck, former director of UCR's College of Engineering Center for Environmental Research and Technology, had a problem. The center had just completed construction and testing of a new high-temperature reactor designed by the United States EPA to convert wood chips into methanol. The reactor did not work to the level needed for commercialization. And while this was a setback, the failure inspired Professor Norbeck to think outside the box, so to speak, concerning the remarkable potential for reactors such as this to help solve the world energy crisis. He had a hunch, and 7 years later, the results of his hunch have proven considerably more successful. This is Lisp, the humbly named Laboratory Integrated Systems Prototype, a product of UCR's unique culture of integrating undergraduate, graduate, and faculty resources in major research projects. Lisp is capable of continuously converting any carbon-based material, from grass clippings to car tires to polyurethane foam, into very clean diesel fuel, while creating no pollution and generating excess steam for electric power.
We had 4 very bright undergraduates that came to me and said, we'd like to work on a project on energy for our capstone course on engineering design. And I had an idea of modifying the system that failed in what we considered to be a more versatile and unique way. Overall, the process consists of 4 steps. The first step, as we had said, is what we call steam pyrolysis. And I use the analogy that it's like putting tough meat in a pressure cooker and heating it for a while and it gets soft. That prepares the material for when you bring in hydrogen, it converts it very quickly to methane. And so the next step is to take the methane and do what's called steam reforming to convert that to CO and hydrogen. And then that you put into a catalyst and you make liquid fuel. So the challenge to the students was to see if this would work. We didn't have any laboratory to do that, but they had computer models that we were going to utilize, and off they went. Well, after the 2 quarters, I remember sitting there in the audience while they made their presentation, in which they said, if you take half of the wood that goes to a landfill, we can replace a major portion of diesel fuel in LA from waste, and we can do it for 65 cents a gallon. And I then immediately said back to them, first of all, you got an A+ in the class, and secondly, put an invention disclosure on this.
Engineering undergraduates have been central to the success of the Lisp project since the beginning, helping to solve myriad technical difficulties in the effort to successfully integrate Lisp's complex series of chemical reactions.
This job gave me an opportunity, everything I learned in class, to apply in real life. My job was to run this and see all the limitations that it has and what we can improve on for a newer reactor and a bigger reactor. Because one of the reasons we wanted to improve this is because our future plan is hopefully to build a pilot plant. So what I was doing is giving them all the results. Based on these results, we were able to calculate the new diameter, height, and all these things that it's necessary to build a new reactor.
Professor Chan Sung Park, a senior partner in the project, helped solve one of the most difficult of Lisp's potential problems, maintaining high pressure throughout the system while taking in raw material and producing fuel continuously.
It looks like a very simple thing, but actually this is the most hardest engineering challenge, because our reactor is very high pressure, and our feed in our world is just 1 atmosphere. So we have to overcome the pressure difference. So we ended with make a slurry with the water, then we can pump it. That there is so many kind of the technology already developed for the pumping against the high pressure. So we decided to use that technology so that it works. So
Lisp holds great promise for an energy-hungry world and has the potential for drastically reducing household, industrial, and human waste as well.
This is the shredded tire coming from the spent tire. This is the agricultural residue. This is especially the bean. This is the wood waste. We shredded wood waste into the particle and we try to gasify it. This is the polyurethane foam. This is the coming from the car seat.
For as Professor Park showed us, it has successfully consumed a wide variety of common waste as source material.
This technology can be used throughout the world. And if you have a country such as Thailand, some areas in South America that have a lot of biomass, you now have a readily available feedstock generated from removing CO2 with sunlight to make fuel. So you don't have any net impact on global climate change such as CO2 emissions. So it's a pretty exciting, promising technology that started with a failure and 4 undergraduates doing a project to graduate. And it's been an interesting experience for us as an organization, and it demonstrates the quality of our students.
For UC Riverside, this is Jim Brown reporting.
Finding alternative sources for fuel is critical because we live in a time where just about everyone is on the move. Here at Davis, these buses are part of the largest student-run bus company in the country. Most of the buses are powered by CNG, that's environmentally friendly compressed natural gas. Now, traffic is pretty orderly here on this campus, but that's not the case in most big cities. That's why researchers at UC Berkeley are trying to figure out just how to make intersections smart. Here's Larissa Brennan.
More than 100 Americans are killed in car accidents every day. Many of those fatalities occur here at the intersections of busy city streets. One of the most common intersection collisions involves drivers making left-hand turns. In fact, left turn crashes make up 1/3 of all intersection collisions, resulting in 9,000 deaths a year and about $500 million in property damage. But a left turn collision is unlikely to occur at this particular intersection. That's because it is a smart intersection. And what makes it so smart?
It has instrumentation. It has communications. So it has a way of talking and listening to cars, and a way of sensing cars, and a way of telling the driver through the car or directly from the intersection what's happening.
Jim Meisner is research manager for Smart Intersection, which is one of several transportation safety projects being developed by California Partners for Advanced Transit and Highways, or PATH. Housed at UC Berkeley's Richmond Field Station, PATH is a collaboration between UC Berkeley and the California Department of Transportation to develop high-tech solutions to ease California's traffic problems. While some projects may never be realized, Meisner says the smart intersection has the potential to make an impact.
As a research team here at PATH, and me in particular, I've had friends who've died at intersections, and I don't want to die at an intersection, so that all means a lot to us. Not all the work that we do can yield tangible results in terms of lives saved, but this is one that could.
Meisner and his team have developed a simple yet effective way to warn drivers of an impending left turn crash using readily available technology like GPS, wireless networks, and radar detectors.
As you approach the intersection, you want to turn left. There'll be devices or sensors on the side of the road that will measure your range and the speed as you approach the intersection. It'll also measure the range and speed of the other car that approaches the intersection. And when it predicts that there could be a conflict, a light on the left-hand side will go on and it'll flash. Don't turn left. Left turn arrow with a slash on it. And as soon as the processor on the side of the road calculates that it's safe to turn, the sign will turn off, and indeed you can proceed through the intersection safely.
Meisner says older cities and towns will benefit most from this system.
The type of street that would do well here are streets where you already have a built-up urban environment and you can't simply widen the street to put a left turn channel or a special lane.
So tell me, how does the smart intersection really work?
This is a box like any other intersection, but when we open it up, you'll see that we put in a computer or the brains behind the smart intersection. And these brains talk to a traffic signal controller, which talks to the traffic signal lights. But also talking to the computer are the sensors. And so we're able to communicate from the sensors to the traffic signal, from the traffic signals to the sensors, and to the flashing signal that you see to warn people not to turn left.
While technology is a main part of the solution, there's also the human factor, and that is how drivers respond to these new systems. Measuring that response is a job of Christopher Nowakowski, who uses this car to test drivers.
The cameras on the dashboard that are looking at the driver are part of an eye tracking system that allow us to monitor where the drivers are looking as they approach an intersection or as they're driving. So we want to know, how do drivers react to the sign, and how do we create the sign and the warning such that it works for people. If you activate the sign too early, people can't figure out if it applies to them, or they might feel that the sign is incorrect. If you activate the sign too late, then you won't have time to respond to the sign and drivers will simply ignore it. And so we think that there's sort of a sweet spot in between where the people will see the sign, know that it applies to them, and agree with the sign and obey it, have enough time to react.
Despite the work that remains to be done, the smart intersection has already attracted a great deal of support from state and federal officials. Recently, Meisner and team showed off their work at a government conference on intelligent vehicle technology, and the response to Smart Intersection was overwhelmingly positive. Meisner says car companies, other states, and municipalities are looking to partner with PATH on this effort. The next step is running tests on city streets. After that, it may take at least 5 years before you'll see a smart intersection in your city. In Berkeley, I'm Larissa Brannon.
So let's see. In about 5 years, we'll have robots at our hospital bedsides, diesel fuel made from garbage in our trucks, smart intersections to keep us safe on the road, and UC Davis graduates working in a firehouse near you. And all of it made possible by work being done at the University of California. Pretty good. That's our program for tonight. Thanks for joining us on State of Minds. Our next broadcast will originate from the first campus in the UC system, UC Berkeley. Until then, have a terrific summer. We'll see you in the fall. I'm George Strait at UC Davis. Good night.